Hello, and welcome back to our Introduction to the C programming language. This is session number 9. Quick recap from last time, we went into the basics of debugging. And we didn't go into too much detail, but honestly, that's okay. It's pretty complicated, and each tool is different. This time around, we'll be going deep into operators and expressions. Operator precedence, casting, and my personal favorite operator, the conditional operator. So, we've been using operators this whole time. Every time you've used a plus or a minus or a star or anything of that sort, you've been using operators. Most of these are fairly intuitive, I would hope. But some of them are a little out there, and they're not commonly used in the math we humans do every day. So it's a good chance to go deeper into them. These four are fairly intuitive. You get your plus, which just adds the two operands together. Your minus, which subtracts the one on the right from the one on the left. The star is the multiplication operator. And the backslash is the division operator. There is one caveat with this. If you are dividing two integers, you will get an integer. And more specifically, the division operator expects both operands to be of the same type. So you can't divide a float by an int or vice versa. And when you divide these two together, you will get the same data type back. So if you try to divide the integer 5 by the integer 2, you're not going to get the float 2.5 back, you're going to get the integer 2 back. You can also think of it as the value being truncated in this case. The percent operator is the modulo operator, which works pretty similarly to integer division. This is only applicable for integers. But instead of returning the integer quotient, you instead get the remainder, also called the modulus. The plus plus and minus minus operators are exceptionally common. And what they do is they will increment or decrement the variable they're applied to by 1. This means it either adds 1 to it or subtracts 1 from it. Apologies. There are two versions of these operators. There's the prefix and the postfix. Both of these are valid ways to use the operators, but they differ in a subtle way. Plus plus a will increment the value and then return the new value. A++ stores a copy of A in memory, increments the original one, and then returns the copy, which still has the old value. Under most circumstances, this isn't going to matter, because a lot of the time you're just doing the plus plus on its own and not as a part of something else. But in the circumstances where it does matter, it's very important to know the difference. It can be the difference between your code working and it not working. So specifically, because of this, these examples are actually wrong. If you look up here, we say a equals 10 and b equals 20. A++ isn't actually 11. A++ will return 10, and then if you use a later, it will be 11. Same goes for here. A minus minus will return the original 10, and then if you use a later, it will return the 9. If you did plus plus a equals 11, that would actually be correct. Logical operators. This set of operators is used for Boolean logic. And what that means is these operators deal with whether a value is 0 or whether it is not 0. C doesn't have a true or false keyword. Instead, what C does is anything that is 0 is considered false when evaluating an expression for whether it's true or false, and anything that is not 0, so 1, -1, the maximum integer value, etc., all of those values are considered true. This will be important when we get to Boolean expressions and flow control in the next session. So, there are five main logical operators. There's the double ampersand, or the double and this is the logical and operator. If both the operand on the left and the operand on the right are not 0, then this whole expression evaluates to 1. If either one of these is 0, then the whole expression evaluates to 0. The opposite of that, well, kind of an opposite, is the double pipe symbol. The pipe symbol is what you get when you hold shift and press the / key. It's above the enter key on an American keyboard. And what happens here is if either A or B, if either the operand on the left or right is not 0, then the whole expression evaluates to 1. If both the left and right operands are 0, the whole expression evaluates to 0. A logical not is used to reverse the state of a Boolean expression. And this can be used on variables, it can be used on more complex expressions that are surrounded in parentheses, like so. And what it does is, if the expression that it's modifying evaluates to 1, it makes it 0, and if it evaluates to 0, it makes it 1. There are a couple of extra operators that aren't listed here because they operate a little differently. There's the comparison operator, which is A double equals B. And if A and B hold the same value, the expression will evaluate to true. So, for example, if you have A holding 1 and B holding 0, A equals B is going to evaluate to 0. If you have A holding 1 and B holding 1, then A equals B evaluates to 1. The opposite of that is a bang equals B, or exclamation equals. A common shorthand for the exclamation symbol is to call it a bang. And so this will evaluate to true if A and B are different, and it will evaluate to false if A and B are the same. These can be used to compare the values of pointers, if you ever need to do that. And then there's these are a bit more complicated. The bitwise operators are part of the C language where the abstraction the programmer can use between what code they're writing and the actual ones and zeros in the computer, and this is where that starts to break down. The bitwise operators operate on the individual ones and zeros of the data in the computer. So the operators we have here are a single ampersand, a single pipe, the caret symbol, which is, let me double check here. Yeah, that's the symbol you get when you press shift and type 6 on an American keyboard. And one that isn't strictly listed here is the tilde, which is the symbol you get when you hold shift and type the key to the left of the 1 on an American keyboard. The ampersand and the pipe do the same thing as they do in the logical operators. They are logical, they're bitwise and bitwise or. And the caret is exclusive or, which is not something we have an operator for in the logical ones. So, there is a truth table here, which can help you figure out what an individual bit will do, or what 2 individual bits will do when subject to this operator. So let's run through that real quick. So we have P and Q. If we set P to 0 and Q to 0, P and Q is obviously 0, P or Q is 0, and P exclusive or Q is 0. The exclusive or is similar to the or with one difference. If both are true, it evaluates to false. So this is used when you need one to be true or the other to be true, but not both. If we set P to 0 and Q to 1, we get P and Q equals 0, P or Q equals 1, and P XOR Q equals 1. If we set them both to 1, we get the values we expect. P and Q is 1, P or Q is 1, P XOR Q is 0. P as 1 and Q is 0 will do the same as P is 0, Q is 1. And you can see that in these two rows here. I have larger examples down here to show that these will operate on every bit of a data type at once. So in here I have given A and B a whole byte separated into sets of 4 bits. So we have A as the binary form of 106 and B as the binary form of 38. A and B, what you'll see here is that every bit that is set to 1 in both of the originals is set in the result, and everything that is either 1 or the other is set to 0. A or B gets the result, A or B will set every bit that is set in either of the originals. So you can see this second bit here is set in A, but not in B, but it's set in the result. A XOR B is a little more complicated. So if it is set in exactly one of the two original operands, it is set in the result. And if it's set in both or neither, it is unset in the result. So you can see here, we have the second bit is set in A, but not in B, and the second bit is set here. The third bit is set in both A and B, so it is unset in A XOR B. And then finally, there is a unary bitwise operator. This is the not operator, which works. It works by flipping the set bits. So if it is set, it is unset, and if it's unset, it gets set. So get 0110 1010 is changed to 1001 0101. And for convenience, I've added the decimal equivalents next to all of these. Typically, you're not going to be using the bitwise operators on numbers. You'll be using them on sets of true or false flags. And they get condensed into one data type in order to make it easier to transport them all at once. So as opposed to sending a whole lot of individual ints or Boolean values to a function, you'll send one integer, and you'll just know in your program which bits are the result of which operations, if that makes sense. It's kind of an advanced technique, and you'll probably learn about it in later courses. Operator precedence. Operator precedence determine what order operations are performed in C. It's similar to when you were learning math in school, the PEMDAS. C has its own way of doing that, which is by and large compatible with that. Operators can have an associativity of either left to right or right to left, which means that when there are multiple instances of that operator on one line, this will determine whether it starts at the rightmost instance of it in the line or the leftmost instance of it in the line, and then it will go left to right or right to left. The most obvious example of a right to left associative operator is the assignment operator, actually. If you have A equals B equals C equals D, etc., all the way up to whatever value you want to assign them all to, the rightmost one gets evaluated first. So D equals 20, and then C equals D, which is 20, and then B equals C, etc. It wouldn't work the other way around because all of the values would just be garbage until you assign them. Other than that, most of them are left to right. I have a link down here that links to a chart that gives you the list of operator precedences and the associativity associated with them. So, assignment and casting. C is very, very type safe. And what that means is C knows what data type is stored in any particular place in memory, and whenever it tries to operate on two different pieces of data, if they don't have the same type, the compiler will complain. Sometimes it will do it for you by converting, say, an integer to a float, but usually it will issue a warning when it does this. There is a special operator you can use called the casting operator. You give it a data type you want to convert something to, and it will do that to the best of its ability. You can cast pointers to different kinds of pointers, or you can cast arithmetic types to other arithmetic types. If you're feeling very, very brave, you can cast arithmetic types to pointers and vice versa, but don't. It's the usefulness of that is very, very niche. I can only think of one particular instance where it was necessary in an operation called the fast inverse square root, which was used in development of, I think it was a game called Quake. And this was necessary to allow the game to run as fast as it needed to. Square root operations at the time were very, very expensive and took a lot of time. Usually, the compiler will sometimes provide implicit type conversions, especially newer compilers, but it will issue warnings when this happens. Programs will sometimes do it when initializing variables, and if the necessary conversion isn't possible, the compiler will give you an error, and it will just not let you do that without explicit instruction to do so. Here's an example of the casting operator. So we have sum defined as an integer here, but we need a double here. So we cast sum to a double by putting double in parens next to the use of the variable, and then this one here is automatically converted because the first operand here is a double. This should produce a warning in the compiler. In more recent ones, it might not, but in older ones, it certainly does. Because the cast operator has pretty high precedence. I think the cast operator has the highest precedence, but don't quote me on that. I haven't checked the chart in a moment. If it does, it shares the highest precedence with a handful of other operators, like the function call operator. The value of sum in this example is first converted to a double, and then because the first one is a double, it sees the division operator and says, okay, I'm doing division with doubles here. Count is not a double, so I'm going to quietly convert it to a double so that the operation can work, and it will then assign this whole value here to the double mean. Certain data type conversions will result in loss of information. For example, if you try to convert an integer to a character, you're losing 3 bytes of information there. And so the compiler will want you to explicitly say that you know what you're doing there. Similarly, if you convert from an integer to an unsigned integer, you're losing some information there because, well, you're changing what the individual bits in the data mean. And so if it is a negative if the integer stores a negative number, you're going to get some wildly high number on the unsigned integer. So the compiler will want explicit casts there. It's also useful to remind yourself and anyone else that's working on your code that there is a type conversion going on here. Last thing we'll go over here is the conditional operator. This is my favorite operator in the C language because it's really strange in how it's typed out, but it's astonishingly useful. Basically, the way it works is there are two symbols that you need to use in order to use this ternary operator. There is a question mark and then the colon. First, what happens is this expression here is evaluated to either 1 or 0. If it evaluates to 1, or, well, not 0, but usually that means 1 in this kind of circumstance. If it evaluates to 1, this expression is the value of the entire ternary expression. If expression 1 evaluates to 0, then expression 3 is the value of the entire ternary expression. This can be used as a very quick and convenient way to get a value out of a test. So say, for example, you need to determine if A and B are different, then you need the value of B. If they are the same, you don't care, so you just take A. Or some other situation. Maybe if A and B are the same, then you need the number 5, and if they're different, then you need the number 92. So you'd say if A equals B here, and then you'd put a 5 here, and then a 92 here. This can also be used as a quick way to, as a very terse, a very condensed way to have an if-else kind of thing. Where this differs from an if-else block is that if and else are statements that control the flow of a program. Those statements don't hold a value, they're just instructions. The ternary operator and the ternary expression, being an expression, holds a value. And they're useful in different ways. Here's a quick example of them, which determines whether we print out that a number is even or a number is odd. So the first thing this does is it gets a number from the user. You have to type in a number, and it will store that in num. Then we have our ternary expression here. So if num mod 2 equals 0, meaning that if you divide number by 2, it doesn't have a remainder, it will print out that the number is even. If the number is not evenly divisible by 2, it will print out odd. So you can see you can have function calls in these expressions too. Next session will be our last session. We'll be going in depth on flow control in C, which means things like if statements or loops that I've been using for a while here. We'll be demystifying those. And we'll have a brief moment about programming style, which is just how you type your code into your text editor and how you make it look so that other people can read it and that you can read it later. As always, there are live sessions for software engineering, software design, C and C++ programming. Thank you for joining us.